This episode is a little follow-up to the last one that will make your lives considerably easier. If you were uncomfortable watching me download, compile, initialize Git submodules and so on, I can tell you there is a pleasant alternative on the way. This alternative is called Docker. Docker is a tool to bundle and deliver applications in so-called containers. These containers are essentially small integrated environments that live on top of a standard Linux stack. We'll get to that in a moment. The good news is the people at Docker are so nice as to provide us with a neat install script, which you can just copy and paste from the transcript as I've done here. When the setup process is complete, it's time to talk about what a Docker image is. Essentially, that's a snapshot of a small Linux virtual machine in a well-defined state. It is formally described by what is called a Docker file, which is at the heart of every Docker-driven implementation. This is ours. Do you recognize it? Basically, that's all the steps we've taken in the previous episode to get up and running with LibPD on Raspbian. The from line just identifies a base Linux image. I've chosen Alpine here because it has a very small footprint and can live entirely in memory. The good thing is, when you build an image, all those steps take place automatically. You can then either just use the image on your machine or go ahead and push it to a repository such as hub.docker.com, which is exactly what I did. And which is the reason why we can do this. Now don't be intimidated, we're just telling Docker to run an image provided by me at snibbles/libpd-raspbian. The --rm flag tells Docker to delete the container once it has stopped. -ti tells it to start with an interactive terminal, the sh command at the end. And --dev/snd specifies the host's, your Raspberry Pi's, sound device to be mapped to the container. The process of downloading and extracting can take a little time on the Pi, please be patient. Now we have a different looking prompt, which means we are now inside our container. We can go to our pdtest-rt-audio directory and run the pdtest-rt-audio application, which worked right out of the box and didn't consume significantly more CPU power, as you can see here. We again copy our test pd patch to the home directory on the host with scp, then again run the Docker container with an additional flag. -v:\root/test, which tells Docker to map our home directory on the host to a specified directory in the container /root/test, which will be initialized if it doesn't exist yet. This is called a bind mount. Inside the container again, we copy our test pd from the root test directory to the pdtest-rt-audio directory and run again. At least on my Pi, this worked instantly. In future episode, I plan to make this process even more automatic. I envision dozens of Raspberry Pis provisioned with Docker to make up a huge installation. If you'd like to learn more about this awesome tool, I'm considering making a whole course dedicated to Docker for creators. Let me know if you'd fancy that, just reach out to me in the comments.